Welcome to Comfort Learn classes. In this video, I will solve questions from relations and functions and we'll stick to just one and onto questions. So let's start with the first question. So here a function f from set of natural numbers to integers defined by f of n is equal to n minus 1 by 2 when n is odd and minus n by 2 when n is even, right? So here we need to check whether this function is 1 1 or onto, right? So the function f is defined from natural numbers to integers. So this is our domain here and this one is codomain, right? Or if you want, you can just take two sets, set A all the natural numbers, set B all the integers, right? And these two are mapped by the function f, right? So now here to check for 1 1, okay, you need not to go for the conventional method that you used in your theory exams. It will take a lot of time. So instead of that, what I will do, I will go for trial and error method, right? So what I will do, we have all the natural numbers here 1 2 3 4 5 till infinity, and here all the integers. So now if I take see here, when n is a odd, you need to take n minus 1 by 2. So here if I take 1 in place of n, so then I will get, let me write it here, if I take f of 1, then I will get 1 minus 1 divided by 2, which is equal to 0, right? So this 1 is related to 0. And if I take f of 2, what is 2? 2 is an even number, so you will get minus 2 by 2, which is minus 1, right? So now here let's take minus 1. So similarly, if I take f of 3, again odd number, 3 minus 1 divided by 2, that is 2 by 2, fine, right? So just keep on taking these numbers, right? So when you solve the same question in your exam, right, you need not to do all these. You can directly write the corresponding elements. So for a better explanation, I am solving it in detail. Now if I take f of 4, again 4 is a even number, right? So minus 4 by 2, so which is minus 2. Again let me take f of 5, so that is odd number, 5 minus 1 divided by 2, that is 4 by 2, which is 2, right? So now just observe the pattern here. 1 is related to 0 and 2 is related to minus 1, 3 is related to 1, 4 is related to minus 2, and then 5 is related to 2. What we can observe here is all the elements from first set have a distinct images, right? So hence it is a 1 1 function. Yes or no? So instead of proving f of x1 is equal to f of x2, here there are two expressions. It will be a bit complicated. It will take time. So instead of that, just stick to this trial and error method, right? So take the random numbers, substitute in the function, just see what are the outputs or what are the images that we get in the second set, right? So now here, take any number, take any natural number, then definitely we'll get a different or distinct images, right? All right. So this is a 1 1 function. Now, as per the options here, you need to check for onto also. Just by 1 1, you can't eliminate any of the options here. So now what I will do, I will check for onto, right? So now, how to check for onto is the function. First of all, you know what is onto, right? Onto, if range is equal to codomain, right? If range is equal to codomain, then the function is called onto. So now here, what is the codomain here? Codomain is all the integers. This set is filled with all the integers. And here, what are the ranges? See here, if you just observe the odd numbers 1, 3, and then 5. 1 is related to 0, 3 to 1, 5 to 2, right? 0, 1, 2. Odd numbers are related to all the 0 and positive integers. What about even numbers? 2 is related to minus 1, 4 is related to minus 2. So all the even numbers are related to negative integers, right? Just let me write it here. So 1, 3, and then 5. The corresponding elements are 0, -1, -2, and if you take 2, 4 which are related to -1, sorry, 2 is related to, check, just a minute, 1 is related to 0, and then 3 is related to 1, and then 5 is related to 2. Again, if you take a even numbers, 2 and 4, 2 is related to -1, and then 4 is related to -2. See here, the first set is filled with all the natural numbers, right? We have infinite numbers here, again integers, all the integers, infinite integers. So now if you go on substituting values as a output or as an image, you will get all the integers, and all the integers will have a distinct pre-image in the first set, right? So the range and the codomain are same, right? So because here, if you take any random number here, for example, if I take -11, okay, so is there any corresponding element in the first set? Because -11 is a integer, you need to just check whether it got any corresponding element in the first set, right? So what we know is negative numbers are related to even numbers, and when the even number is given, you need to take this -n/2. So -n/2 is equal to -11, then you will get the corresponding n value, right? So minus and minus will cancel out, then n is equal to 22, right? So what is the corresponding element here? That is 22. So similarly, you take any integer, you will get a distinct pre-image in the first set, all right? Hence it is both 1 1 and 1 2. So the correct option is D. Okay, let's solve one more question. So here the function is given by g of x is equal to x square minus 4x minus 5. So we all know this is a quadratic equation, right? So now we need to prove again whether the function is 1 1 or onto, right? So here but let me just go through the options given. G is 1 1 on R, G is not 1 1 on R, G is bijective, and none of these, right? So first start with 1 1 and just check whether the given function is 1 1, right? So we all know the solutions for quadratic equations is 2, right? If you take x square minus 4x minus 5 is equal to 0, and when you solve this, then you will get two solutions, that is alpha and beta, right? Or x1 and x2, right? So now if I take two sets, that is set A and then set B, and as the function is defined from R or defined on R, both the domain and codomain are real numbers, right? The set A is filled with all the real numbers, and set B again all the real numbers. So this set will have x values, right? X belongs to R. This set will have x values, and this set will have g of x, right? So now here this is equal to g of x. Fine. So then if g of x is 0, then what are the corresponding elements? Alpha and beta. Alpha is related to 0, and then beta is also related to 0, right? So hence, as two elements are related to 0, it is definitely not 1 1 function, right? So see, when you get such questions in KCET, you need not to solve it in detail, because you will be having hardly 1 minute for per question, or like we all know, right? There are 60 questions and the time given is 80 minutes. So instead of solving the whole question, if you just know the concept, or if you have the clarity over the concept, then you can solve it in within 5 seconds or less than 5 seconds, because quadratic equation and the options given here, G is 1 1, definitely no, because we know it is on 2. So if it is not on 1, neither on 2, and option 2 not 1 1 or many 1, right? So the correct option is 2, right? So if you want me to explain it in detail, see here, x square minus 4x minus 5 is equal to 0. If you solve this, you will get x square minus 5x plus x minus 5 is equal to 0. And then if you take common, x minus 5, if you take 1, x minus 5 is equal to 0. So x minus 5 and then x plus 1 is equal to 0, right? So you will get x is equal to 5 and x is equal to 1. So here, okay, when you take x is equal to 5 or when you take x is equal to 5 or x is equal to 1, then the corresponding element will be 0, right? Because here this is the function. If you put 5, you will get 0. If you put 1, again you will get 0. So 5 and 1 are related to 0, hence it is not 1 function, right? Okay, let me explain how to check the same function whether onto or not. So not 1 function. Now how to check for onto, okay, without the conventional proof. So now here we all know this is related to this function by g of x, that is our quadratic equation. So now I will take 10 from the second set because 10 is a real number, right? So here this is my g of x, and what is our g of x here? X square minus 4x minus 5 is equal to 10. That is g of x, right? So if you take this 10 here, one sec, let me take minus 10. Okay, let me take a minus 10 here. So you will get x square minus 4x minus 5 plus 10 is equal to 0. Okay, and x square minus 4x plus 5 is equal to 0. All right. So now here, if you solve this equation, so you know quadratic formula. What is the quadratic formula? X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. Okay. So now here, if you want this x to be a real number, right? Because x is a domain and it belongs to real number. If x must be a real number, then this b square minus 4ac must be greater than or equal to 0. We all know this condition, right? You learned it in class 10th. This b square minus 4ac must be greater than or equal to 0. Then only we'll get x as a real number, right? So now here, if you substitute or if you find this b square minus 4ac for this question, so what you will get? What is b square minus 4 square minus 4 into a and c here? So you will get 16 minus 20, which is equal to minus 4, right? So in this case, you will get x is equal to minus b plus or minus root of minus 4 divided by 2a, right? You can substitute a and b value, but you will be left with minus 4 in the root, and we know minus 4 in the root is a imaginary number, right? So there is no corresponding element for minus 10. If I take minus 10 here, there is no corresponding element in the first set. So what does it mean? Range is not equal to codomain, because what is codomain? All the real numbers, but this minus 10 is not having a pre-image in the first set. So range is not equal to codomain, hence the function is not onto. Fine. Okay, so actually it won't take this much time. Just wanted to explain you or give a better clarity over this one on onto when a quadratic equation is given, right? So again the conditions will change when you have natural number to natural numbers, when the function is different from this, if the function is different from integers to integers, right? So before solving any questions on this one on and onto, you must check whether the domain and codomain are natural, integers or real numbers. Okay, solve one more similar question. Again here the function is given as 1 plus n square, which is a quadratic expression, and here the function is different from n to n, right? So the first set and the second set, okay, that is your domain and codomain, both are natural numbers, right? And these two are mapped by the function that is 1 plus n square. So again we need to check whether this function is 1 or onto, right? So natural numbers 1, 2, 3, 4 and 5 till infinity. Okay, so these are the natural numbers here. So now we need to check for 1 and onto. Again, don't go for the conventional method, just take some numbers. For example, 1 plus n square. The function f is, or f of n is 1 plus n square, right? So then what is f of 1? F of 1 is 1 plus 1 square, that is 2. And what about f of 2? That is 1 plus 2 square, 5. And f of 3, 1 plus 3 square, that is 10, right? So 1 is, let me map it here. 1 is related to 2, and then 2 is related to 5, and then 3 is related to, just so 3 is related to 10 here. Okay, it goes on. All right, so what we observe here is each element from set A are having a distinct elements in set B, right? If I take 4, again I will get a distinct element. If I take 5, still one more distinct element. Fine. So now here, what is the conclusion here is, it is a 1-1 function from this observation, right? But here if you just go through the options, in all the options we have this both 1-1 and onto, right? So you can't eliminate again any options with 1-1, better check for onto, right? So now is this an onto function? See here, again condition, range must be equal to codomain. Okay, for the function to be onto, range must be same as codomain. So here what is the codomain? Codomain is all the natural numbers, right? But here if you observe, what is the pre-image of 1 in the first case? What about 3? What about 4? Right? So now what I will do, I will take 1 plus n square is equal to 1. Then we will get a n value, that must be the pre-image. So if you solve this, you will get n square is equal to 1 minus 1, or n square is equal to 0, or you will get n is equal to 0. Right? So what is the pre-image of 1? That is 0. But what is the first set? It is a natural number, so there is no 0 in the first set, right? So there is, similarly there won't be any pre-images for 1, 3 or remaining numbers. Hence the range and codomain are not same, because there are some elements are left out in the second set. Okay, if any element is left out in the second set, then it is not a onto function. Okay, so then neither one, okay, 1-1 but not onto. Okay, that is our option C. The function is 1-1 but it is not onto. Fine. Okay, let's solve one more question. So here set X is having the elements -1, 0 and 1, and set Y is having 0 and 2. So the function is different from X to Y, so this is your domain here, and the second set again codomain, right? And what is the relation, how these two are related? So the relation given is y is equal to 2 into x raised to 4. Now again check for 1-1 and onto. So now here, as the 3 elements are given, just substitute these elements in the function and find the corresponding values. For example, what about f of -1? That will be 2 minus 1 raised to 4. So which is equal to 2. What about f of 0? That will be 2, 0 raised to 4, which is 0 again. So f of 1, that is 2, 1 raised to 4, that is 2. So if you take sets, that is your domain and codomain. So here we have -1, 0 and then 1. And here we have 0 and then 2. That is our codomain. And -1 is related to, okay, and 0 is related to 0. 1 is again related to 2. So the function is many 1. Okay, is it onto? Yes, the domain, codomain and the range is same. There is no elements left out in the second set, so it is onto. So the correct option, many 1 and onto. Okay, fine.